Hello guys, so today I'll be solving another LeetCode problem, which is the problem of the day. The problem is 225. It's an easy problem where we have to implement the stack using queues. We have to implement a last in first out LeetCode stack using only two queues. So we have to implement a stack using two queues. The implemented stack should support all the functions of a normal stack like push, top, pop and empty. We have to implement the myStack class, the class that is given, and it has the following functions. A void push, a push function which doesn't return anything. It pushes the element x to the top of the stack. Int pop, where it removes the element on the top of the stack and returns it. Int top, it returns the element on the top of the stack. And a Boolean empty method which returns true if the stack is empty and false otherwise. So they have also given a note, you must use only standard operations of a queue, okay, which means that only push to back, peek or pop from the front, and size and is empty operations are valid. Okay, so these are the valid operations of the queue that can be used to implement the stack. Depending on the language, the queue may not be supported natively. You may stimulate a queue using a list or a DQ or double init queue, as long as you only use a queue standard operations. Okay, so basically what they are trying to say is that we have to implement a stack using two queues, and we have to use only the standard operations of the queue to implement the stack. So they have in the example they have passed myStack, which is the constructor. Then it is asked to push two push operations followed by one top, one pop operation, and then one empty. So this will constructor will return null. Push will also return null because it is void. Another one is push, so it will also return null. Top should return 2, and pop should also return 2, and empty should return false. So this is the myStack. They are initializing it. myStack.push, they have pushed 1 and 2 here, and then top will return 2 and pop will return 2. Okay, so this is the constraint. At most 100 calls will be made to push, pop, top and empty, and all the calls to pop and top are valid. Okay, so to implement this, first we need to understand that a stack follows LeetCode, last in first out. So stack can be visualized as a deck of CD. So the last CD that will be added to the deck will be removed first, and a queue can be visualized as people standing in a line or a queue, where the person standing in the first who has entered first will move out first. So that is the basic operation, and we'll be using two queues to implement the stack. So we must stimulate a queue using a list. So we have to use a list or a DQ to implement them. For that, first we will initialize those. I'll be using a list. To implement. Okay, so now the first operation. Now suppose this, for reference sake, the queue will be 1 2 3 4, and this is another queue, and the so this is the 1 is the first element, it has been added first. 2 is the second element, 3 is the third, and 4 is the fourth. So in normal queue, the element that will be removed first is 1, then 2, then 3, and then 4. But we have to implement a stack. So in stack the element will be like so. 1 will be added first, then 2 will be there, 2 will be added, then 3 will be added, and then 4 will be added. So this is a stack representation. So here in stack the first element that needs to be removed is 4. So we need to make sure that in this queue the first element that is removed is 4, not 1. So this we have to implement. Okay. So q1 we need to add the elements. We need to add the elements into the queue because that is the first operation. So we will add it, and this will be the top of the stack. Okay, so we need to define a we'll define a top variable to keep track of the top, and this is the top of the stack right now. Okay, now what this will take O of 1 like the time complexity will be O of 1 for this push operation. To perform pop is where we need to understand this. What we will do, we need to remove 4 first, because this is what stack does. We need to remove the last in will be the first out. So 4 in stack, 4 will be the last element that is added, and this will be the first element that is removed from the stack. So for that what we will do, we will copy each element from q1 to q2. So 1 will be, we'll add 1, we'll add 2, and we'll add 3 in q2, but not 4. Because so after performing this, there will be only the last element in q1 that will be left, because we have removed everything from q1 1, 2 and 3, and we have added it to q2 1, 2 and 3. So now only 4 will be left in the in the q1, and we will remove it, and after that, after removing, we will assign this queue will be q1. So this is what q1 remains. So for that what we will do, so till when we have to run this, till the size is 1, because that is the last element. So size of the element will be 1. So we will run a while loop till q1 dot size is should be greater than 1. So we need to add those elements in q2, right? So we'll keep track of the top. q1 dot will remove each element from q1, and we'll add them to the second queue that we have defined. Okay, now q1 is left with only one element, and that element will store in a variable, and we'll remove it because it is in pop, right? So we'll remove it. Now we need to copy all the elements from q2 back to q1. So for that we will define a temporary queue, and we'll assign it q1, and then we'll copy it. Like this is similar to we are exchanging the values in two variables using a third variable. So this is similar to like that. So q1 will equal to q2, q2 equal to temp. Okay, so now what we have done, again we have removed this for top was q1 dot remove, so it top has 4 int answer has q1 dot remove, so answer we have taken and we have removed it. So right now this is empty, and after interchanging the values, what we have 1, 2 and 3 here, and again now q2 is empty, and after performing this we'll return answer. Okay, now what top will do, top will just, it will not remove the last element, it will it will just return, it will not remove. So we'll be performing the same operation that we have done earlier for pop method. q1 dot size should be greater than 1. Okay, we'll assign top and then q2 dot add, and we'll add the top here. Okay, now again we'll assign int answer equal to q1 dot, sorry, not remove, remove we should not, remove we don't need to do, we need to do peek operation to store the value. So we are not removing the value, we are just storing the value, and after this again we'll take all the values back into q1. So again okay, so we have again assigned everything back to q1, and the last method that we need to implement is Boolean is empty. So for that we'll just return, okay, we need to return here also, we'll return the top which is storing the last element, and here we'll just return q1 dot 1 is empty. Okay, I think everything is done. I need to remove this. Okay, this will be q1. Okay, I know what the error is. So what we have done here, we have stored answer, but we have forgot to remove it. So q1 dot remove, and we need to add. Okay, I think this should solve it. Yes. Okay. Okay, so we have done this. Yes, okay. Now what they are saying is, follow up, can we implement the stack using only one queue? So we have to implement the stack using only one queue, right? So to implement stack only using one queue, what we need to do is, we need to understand how we will do that. So for that we'll be using, since only one queue, so Let's first define an queue. We have defined a queue using a list, and we'll be adding the element to the queue. So we have added it, right? Now what? Suppose we have added one here. Now next, that the elements that we need to add are 2, 3 and 4. So but if we add 2 in a queue, it will come after 1, and then after 2, 3 will come, then 4 will come. But what we need to make sure, that in stack the elements will be from the top to bottom, it will be 4, 3, 2, 1. So what we will do, we need to make sure that 2, 3 and 4 are added before 1. So instead of this, it should be 4, 3, 2 and 1. It should be like this. Okay, so how we need to implement this? So what we will do, we will run a loop from I equal to 0 to q dot size -1 I plus plus. Okay, so now we are whenever we add, we will be adding like this, but we need to make sure that this after adding and performing this, it should come out like this. So for that, what we will do, we will poll every element, and we will add it to the end. So this is what we will do. We q dot add and q dot poll. So what does poll do? It will remove. So for q, it will be first and first 1 will be removed, then 2 will be removed, and 3, 4, and then it will be added 4, 3, 2 and 1. So this is what we are doing. And for pop, we will return q dot poll. For top, we will return q dot peak, and for checking empty, we will return q dot is empty. Okay, I think this should do it. I hope this statement is not push q. I hope this statement is clear. I don't have a whiteboard, but this is what it is actually doing. Let me run it again. Missing return statement. Okay, sorry. Okay, now we'll submit this. Okay, so it has submitted and we have done this. I hope this is clear. Thank you. If you like the video, do like it, because subscribing is, let me be consistent, then you can subscribe. Okay, thank you.